Hi everyone and welcome to Smart Culture Education. This is the place where we make learning simple, clear and engaging. If you're new here, don't forget to subscribe so you can join us on this journey of mastering maths, science and more. Luckily, it will be given to you on a formula sheet so you don't have to memorize all of it. Okay, so there are 6 compound angle formulae, also known as addition formulae. 2 for each. 2 for sine, 2 for cosine, and 2 for tangent. Now, let's start with the compound angle formula for sine. Okay, now the first one says sine of A plus B is identically equal to sine of A multiplied by cosine of B plus cosine of A multiplied by the sine of B. I want you to write it down. And then the second one, sine of A minus B is identically equal to sine of A multiplied by the cosine of B minus the cosine of A multiplied by the sine of B. So for sine, the positive and negative sign on the left-hand side matches the one on the right-hand side. So here we have a plus, here we have a plus, here we have a minus, here we have a minus. Okay, moving on to cosine. Let's have a look at the first one. The cosine of A plus B is identically equal to the cosine of A multiplied by the cosine of B minus the sine of A multiplied by the sine of B. Let's have a look at the second one. The cosine of A minus B is identically equal to the cosine of A multiplied by the cosine of B plus the sine of A multiplied by the sine of B. Now, for cosine, the positive and negative sign on the left-hand side is actually opposite to the one on the right-hand side. So here we have a plus, here we have a minus, and here we have a minus, and here we have a plus. Let's look at the tangent formulae. Let's have a look at the first one. Tangent of A plus B is identically equal to the tangent of A plus the tangent of B divided by 1 minus the tangent of A multiplied by the tangent of B. And then we have another one. The tangent of A minus B is identically equal to the tangent of A minus the tangent of B divided by 1 plus the tangent of A multiplied by the tangent of B. Now, for the tangent formulae, the positive and negative sign on the left-hand side actually matches the one in the numerator on the right-hand side. And it is opposite to the one in the denominator. So here we have a plus. It matches the sign in the numerator, but it is opposite to the sign in the denominator. Here we have a minus. It matches the sign in the numerator, but it is opposite to the sign in the denominator. Okay, now you can actually derive the tan identity by writing the tangent of A plus B is identically equal to the sine of A plus B divided by the cosine of A plus B, dividing the numerator and denominator by cosine A multiplied by cosine B. Okay, so what we are going to do now, I hope that you guys have written down all of these formulae. Let's have a look at some example questions. Question A, express the tangent of 225 degrees minus 30 degrees in terms of tangent 225 degrees and tangent of 30 degrees. So I'm going to start with question A. Okay, so what I want you to do is I want you to focus on this formula that we've learned. I want you to focus on this formula over here. Okay, so I'm going to write it down. So the tangent of A minus B is identically equal to the tangent of A minus the tangent of B divided by 1 plus tangent of A multiplied by tangent of B. And as you can see, it matches this compound formula exactly. Now we have to express the tangent of 225 degrees minus 30 degrees in terms of tangent 225 degrees and tangent of 30 degrees. So it will look like this. The tangent of 225 degrees minus 30 degrees will be identically equal to tangent of A, in this case, A is 225 degrees, minus the tangent of B, now in this case B is equal to 30 degrees, divided by 1 plus tangent of A multiplied by tangent of B. So it's going to be 1 plus the tangent of 225 degrees multiplied by the tangent of 30 degrees. Okay, so this is fairly easy. And now we have to move on to question B. Hence, show that the tangent of 195 degrees is equal to 2 minus square root of 3. So I'm going to do part B with you guys because this one is a little bit tricky. Okay, so 225 degrees minus 30 degrees is equal to 195 degrees, right? So let's start with the tangent of 225 degrees. If you punch this into your calculator, or if you visualize the tangent graph, you will see that the value of the tangent of 225 degrees is equal to 1. And the value of the tangent of 30 degrees is equal to square root 3 over 3. Now, you should know that the tangent of 30 degrees is equal to the square root of 3 divided by 3. Where is this coming from? Okay, so what I'm going to do is I'm quickly going to just give you guys the background knowledge, just as a recap. Now, let's say we have an equilateral triangle over here, and that means that this angle will be 60 degrees, this angle will be 60 degrees, and this angle here will also be equal to 60 degrees. And let's say the sides are all equal, it's 2 units. Now, what we are going to do is we are going to split this triangle in half. Okay, we are splitting this triangle in half. So that means this angle here is equal to 30 degrees. And now we want to work out the length of this side over here. So we want to work out the length of this orange side over here, and for now I'm going to call it x. Okay, so if we take a look at our triangle over here, we can see that we have a right angled triangle, which means we can use Pythagoras to determine the missing side. So our hypotenuse is equal to 2 units. This side here will be 1 unit, and this side is unknown, it's x. So according to Pythagoras, x squared is equal to 2 squared minus 1 squared. Now 2 squared is equal to 4, 1 squared is equal to 1, so x squared is equal to 4 minus 1, which is 3. Now I don't want to know the value of x squared, I want to know the value of x. So what do? I add a square root, the square root and the square will cancel out, so I'm just left with x. Whatever I do on the one side, I have to do on the other side as well, which means I have to add a square root to this side as well. So that means x is equal to square root of 3. All right, so now I have the length of x. Now, according to the sine ratios, we know that tangent of theta is equal to the opposite side over the adjacent side. Okay, in this case, it will be 1 over square root 3, because if we take a look at the opposite side, here we have the 30 degree angle, so the tangent of 30 degrees is equal to 1 over the square root of 3, because the opposite side of the 30 degree angle is equal to 1, and the adjacent side is equal to x, which we determined is the square root of 3. So that is where the 1 over square root of 3 comes from. Now we want to remove the square root from the denominator. So what do? We multiply. All right, now square root 3 times square root 3 is equal to 3. And 1 times the square root of 3 is equal to the square root of 3. So that is where this tangent of 30 is equal to square root 3 over 3 is coming from, just to refresh your memory. So now we can write down the tangent of 195 degrees is equal to the tangent of 225 degrees minus 30 degrees. Now we can follow this part over here. So the tangent of 225 degrees is equal to 1. So instead of writing tangent 225 degrees, we are writing a 1. Then we have to subtract tangent of 30 degrees, and we know that the tangent of 30 degrees is equal to square root 3 divided by 3. And we have to divide this by 1 plus the tangent of 225 degrees. We know that is also equal to 1. And we have to, of course, multiply this by the tangent of 30 degrees, which we know is equal to square root 3 divided by 3. Now we have to solve this. Okay, so it will be 1 minus square root 3 over 3 divided by 1 plus square root 3 over 3. All right, now what we are going to do now is we are going to rationalize the denominator. So it becomes 3 minus the square root of 3 divided by 3 plus the square root of 3. Now we rationalize the denominator, and that brings us to an answer of 12 minus 6 square root 3 divided by 6. And if you simplify that, you will get 2 minus square root 3. So what I want to do is I want to get back to this part over here. Okay, so let's look at this first part over here. Okay, so it's actually 1 over 1 minus square root 3 over 3. Now, if we subtract two fractions, we have to make the denominators the same, right? So what are we going to do? We have to multiply this by 3, because the LCM, the lowest common denominator, will then, the lowest common denominator in this case will then be 3. This denominator is already 3, so that means we have to change the denominator of this fraction over here on the left-hand side. We have to multiply it by 3. Whatever we do at the bottom, we have to do at the top as well. So then we have 3 over 3 minus square root 3 divided by 3. Okay, and then the same for here at the bottom. So then we have 3 over 3 minus square root 3 over 3 divided by, this will become 1 over 1 plus square root 3 over 3, and then we have to change the denominator to 3 as well. Okay, so it's 3 over 3 plus the square root of 3 over 3. Okay, so that's how we come to this section over here. All right, so we have now proved part B as well. Here we get 2 minus square root 3, 2 minus square root.
Thank you for watching today's video on Smart Culture Education. If you found it helpful, don't forget to hit the like button and subscribe to the channel. And if you want to stay updated, tap the notification bell so you never miss our next lesson. See you in the next video.